Good afternoon. I'm Barbara from HP. I'm a field specialist for Hewlett-Packard, what used to be what our name was, but now we separated about 2-3 years ago into two different companies. You probably are familiar with Hewlett-Packard from your personal systems. Well, we're known as HP, and underneath the HP banner, we have several different divisions, several things that we do, but we're here today to talk to you about 3D printing. 3D printing for HP is an exciting new area for us. We believe that this is the future of manufacturing, and one of the reasons that we got into 3D printing is because we want a piece of that $12 trillion manufacturing area. 3D printing represents integration, disruption, as well as the ability to make more profit. This impacts production by allowing you to get parts faster, integrate it into your manufacturing floor, and do things that you couldn't do before. As part of our portfolio of products that we offer, we're showcasing the 580 machine today. The 580 machine is really oriented toward doing parts at around 100 pieces per week and below for those that are wanting to do true prototypes with jigs, fixtures, accessories, etc. added into the product mix. We're going to be talking about this machine in particular, which is the machine that does color also as part of our portfolio. At the end of the presentation, I'll be talking about the complete range of machines, including the 4200 series and the 5200 series, as well as we're going to do a little bit of a deep dive into some of the technical details. My associate Brent is going to come up and he's going to talk about those tech areas, and I'm going to be talking more about applications, how you really use this machine. So first of all, let me tell you some general things about the machine. The 580 in our portfolio is an all-inclusive solution. That means that you print, you clean, you do everything within this footprint of the machine. If you open up the lid, you can actually see the printing area. You have a carriage that dispenses ink, as well as has a heat source. Now, we're a little bit different. Multi-jet fusion uses a heat source and actually fuse the material into a part. It's not binder jetting, it's not lasering, it's not doing fused deposition modeling. It actually is a completely unique process called multi-jet fusion. Multi-jet fusion applies the same principle that you have when you go out on a summer day in a black t-shirt. You get hot. Well, by having an ink that attracts that heat, we actually melt that polymer down and fuse it. And because we have entanglement of molecular strands between layers, we get a fully dense part. It's isotropic, it's fully dense without voids, and it's uniform throughout. When you look at this machine, you have three distinct areas, and we're going to get more in the technical details, but the three distinct areas you have your print area with your carriages for both spreading powder and for dispensing the ink, or what we call the fusing agent, and the detailing agent, which acts as a masking tape. It prevents thermal bleed into the adjacent areas. Then you also come down to things that you're very familiar with from if you've used HP products in your personal life. If you look here, you have your agent dispensing area. This is a plug and play aspect of it where you have both colors, the fusing and the detailing agents dispensed. And on this side, you also have the materials area. Now, we haven't got the materials canister in it right now, but you have the ability to both recycle the content of the materials up here that you haven't used in the build of the part into the machine itself, ratio about 80% of reusability, and it mixes it right there in the machine. We also have the virgin material, the canister, and it has an internal auger that allows you to feed the material through the machine automatically. The carriage system, when you have the powder play over the build area, your carriage system will come through, and you notice I'm going to move it slowly. The carriage system comes through and dispenses the fusing and detailing agent, as well as it has the heat source. Comes over the build area, all the way to the side, and it comes back, and then the material plays through. As you fuse the part, the platform will lower. You also have the ability to make sure that there's monitoring of any hot spots or cold spots so that we can apply heat, and you'll have the differential monitored and applied at the same time. Now, where does this go in your manufacturing area? In this particular machine, it allows you to have durable prototypes. What does that mean? Well, this is a great example. If you look at this little can, you can see obviously that this has got an FEA this pattern on it. But more than that, it doesn't break. And so, thank you. So it's durable. So you can do things with this that in a lot of your aspects that you have got prototypes being done in your plants right now, if you dropped it, threw up in the air, usually your user has a heart attack because they're afraid it's going to break. So this gives you a lot of options. Additionally, it lets you do intricate details in different colors. Now this little chest piece has an outer layer, but you also have the inner colored layer. So it allows you to do all these detailed pieces and get your accuracy, reproducibility in a durable part. So if you guys want to look at this, pass it around. Now don't take it though, you promise you'll give it back? I'm not sure I'm going to give this to you. Okay, all right. Didn't get agreement from the crowd, so we won't pass that around. I can see that it was going to disappear. So when you look at this machine, what does that mean for you on the manufacturing floor? That means that you get the color, you get the durability, you get the ability with the accuracy and the reproducibility in an affordable solution. HP offers you a lot of ways to get this machine and integrate it into your manufacturing. Is it going to replace injection molding? No. But should you integrate it into your factory to give you another option on those jobs that you no quote, on the things that you can't do now easily, on things that you're having short run and you have to store the tools forever? This gives you a lot of options. So we've got 3 machines that go into that, and I'm going to turn this over to Brent, and he's going to talk about the technical details of the machine. And then you can ask us some questions about build ratios, accuracy, area, etc. That we've got the information here for you. Also, I want to invite you, we've got literature here that has comparisons of the different machines in our entire portfolio, as well as we talk about specific features of this machine. That includes color, that includes a smaller footprint, and it includes being able to have a cost-effective solution on your manufacturing floor. So let me turn it over to Brent and let him take it away.
Thank you, Barbara. Hi there, everyone. I'm Brent Ewald. I'm an applications engineer based out of the Midwest. I actually used to work research and development on this printer. So what I'm going to talk to you today, she already covered a lot of the basics about how this printer works. You know, you recoat powder, you mask where you want the part, you melt it with energy. What I'm going to talk to you about is the science of color in our parts. So when you think of our parts, you know, these solid objects, how would you go about putting color on it? You need to absorb energy. That's the key component to our process. So a very exciting thing our ink chemist developed was a bright fusing agent. This is an ink agent that is absorptive in the IR spectrum and transparent in the visible spectrum. So to us, it appears to be white or clear, and to the lamps, the energy that we're melting with, it appears black. This is really exciting. And the way we get color from here is we use black fusing agent, and then we create a shell around the outside. And on that shell, we apply color. At this point, we have a white piece of paper, and it's just like printing 2D. We can leverage our 30 years of printing excellence to create the type of colors and parts you would expect from an HP color printer. Now, the other thing, though, is there's an economic aspect to it. So we kind of adopted what we term a geological model. So you have the core, the mantle, the crust, and so what we've done is we keep that core black to save everyone money, and it's a great economic design. And then you have the mantle around the outside, and then the color. The nice color you see here is just on that outer layer. So color is only skin deep. Anyways, I'm going to turn it back to Barbara to talk more about the portfolio and how it exists in your manufacturing.
So whenever we look at the portfolio and all the things that we do at HP, one of the things about HP that you probably know about us is that we can dispense ink and liquids better than anybody else in the world, because we've taken that 2D expertise and applied it to 3D. Now, why did we decide to go into 3D printing? If you think about where HP has always been, that's been printing. We started with paper, then we went to other media. That included metals, like the Coke cans, and packaging. And then we went to latex, we went to wall coverings, we went to page-wide printers, we went to signage, we went to all sorts of digital printing. So it's a natural evolution that we went to 3D printing. And in fact, in our portfolio coming up very soon, we're actually adding more materials every day, both in 2D and in 3D. And more importantly, we continue to evolve. Because we're an evolutionary type of technology, it continues to improve. As that improvement, we look at different products that fit into your manufacturing needs. And so we have a portfolio. When you look at the 5200, which is the high volume production machine, which is really meant to give you options that you couldn't enjoy otherwise for both manufacturing, tools, assembly aids, production, it gives you the ability to do a whole range of products that you couldn't approach without tooling before. Then you have the 4200, which is a bridge between the prototyping to production, and then you have the 500 series, which is really aimed solidly at prototyping as well as fixturing. So when you look at our entire portfolio range, what's going to be next? Well, in 2021, we're going to be printing metals. So I invite you to come back and see me in 2 years when you can buy a metal machine. You can buy parts right now through our website because we partnered with 2 service bureau companies that allow you to get metal parts right now as our platform evolves and gets finalized. The other thing that we're doing is we're looking at applications. 3D printing and additive manufacturing really are integrated into your entire manufacturing workflow. We want to be able to give you options that you couldn't enjoy before. Those options mean toolless parts, volumes that you couldn't get at, and ability to quote product that you haven't been able to quote before. If you'd like to have more information, please see me or see Brent. We're going to get information to you, but we also have some literature in the booth, but this is also the machine. So I'm Barbara, this is Brent. I'm going to open it up for questions right now. And I'm going to repeat the questions so that they can hear it throughout the audience. Any questions? Crickets. Come on, guys. What's the material? The materials are nylons in most cases. We have a nylon 12, a nylon 11, a nylon 12 glass bead, and the thermoplastic urethane. Now, people ask me, and you guys are all in the plastic processing business, what's the difference between a thermoplastic and a thermoset? Here's a great example. If you have butter and pancakes in the morning, if you have pancakes, that's a thermoset because you can't go back and put it in the box. If you have butter, you melt it, but you can actually have a solid patty of butter again because it'll transition back to a solid. So that's kind of the same difference between a thermoplastic and a thermoset. You can't put the pancake back, but you can put the butter back. And you'll never forget that example, will you? So any other questions?
Yes.
Yeah, we have the urethane. And one of the things that you have to...
So this is the urethane that's being asked about. It has variable lattice structures here, and you can see different levels of essentially softness with the same material. So the idea behind this is you shouldn't let the material limit what you can do with it.
Yeah. And if you look at, this is a prime example of how design also affects the resiliency of the part. The thinner, the latest work on that, the more you can squish it down. The thicker, the stiffer it appears. It's the same thing on nylon 11, for example, which is a more flexible material that we offer. It gives you options if you want higher impact materials. 12 is kind of the bell ringer. It's the one that's most often used, and it gives you exceptional stiffness, elongation, strength, impact strength, etc. Exceptional. Does this replace injection molding is another question I get answered. No, it absolutely doesn't. If you need to do 5 million parts in a year, you're going to want to injection mold it. You're going to do 1 million parts a year, you're going to want to injection mold it. If you want to do 20,000 parts a year though, we probably need to talk, especially if you've got that spread out throughout the entire year. And we all have customers that want to come up and they want to do parts, but they only want a few at a time. This allows you to do JIT manufacturing. It allows you to avoid having to store a tool, and it also allows you to quote the jobs that you couldn't quote before.
As an example of that, I would challenge you to make this impeller with less than a 5-axis mill or injection mold it in less than 3 parts.
Yeah, good example. And then I have a more complex impeller. I believe that one's over there. It's almost impossible to mold because of the curvature of the fins. We're seeing more and more customers want lightweighting as another option. You know, whenever you look at this compared to aluminum, for example, in a cast part, this gives you lightweighting savings as well as impact resistance, as well as some design aspects that you couldn't have gotten any other way. It allows you to do thinner parts. It allows you to do lattice work. It allows you to do things that you didn't think about before. In fact, we do a lot of design for additive manufacturing seminars, and what we do is we ask you to go all the way back to the concept development and get to the root cause of what you want that part to do. Then you truly develop a design for additive manufacturing part rather than just duplicating what you've already done in other methods.
Where we end up finding parts in final production are where you have added value that you've unlocked with additive manufacturing. I just wanted to repeat a question I received.
Yes.
Someone asked how long it takes to print a part, and the way we frame that question is actually we tell you how long it takes to print a volume. Because our process is area-based, it doesn't matter how the individual part, because you want to utilize as much of the bed as you can. But you have a nice cheat sheet here, I believe.
Yes, I do.
So
I'm in sales. I can't memorize a whole lot, so I have to have a cheat sheet. So on the cheat sheet, let me just tell you what the volume aspects are. In the 5200, that's our highest volume machine, you have a build speed of 309 inches cubed per hour. In the 4200, that's the mid-range machine, you have a build speed of 251 inches cubed per hour. Yes, you can tell we're very accurate and we really test a lot of these machines. In the 580 machine, which we have here, that's 111 cubic inches per hour. Now, in part of that build, one of the things that I always tell customers to be aware of is that your build is only half of it. You can print, but you need to cool. And why do you cool? You make sure that your part doesn't warp during your cooling. So we usually suggest that you do ambient cooling that allows the part to cool down without warpage and without drawing materials from other hot areas of the part. Just like you do in injection molding. You have to be a little careful on how you cool it. Any other questions? Well, I want to tell you today that please stop by and see us, answer, ask, as well as point out things that you want to see in 3D printing because we're constantly evolving this platform. I am proud to be a part of HP. I have to tell you, if you ever have a chance to come work for HP, you got to do it. It's one of the greatest companies to work for, and I love what I do. I am a 3D printing geek. I'm living the dream. You got to come see me. This is Barbara, and thank you so much for showing up today. Appreciate it, guys.
Thank you.